Hello, everyone. Good morning, afternoon, evening. Dear authors and invited guests, welcome to Technical Session 2C. Myself, Ashutosh Goel, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you all to the International Conference on Technological Intelligence and Business Strategies, TIBS 2026, Manila, Philippines. This conference is being organized in a hybrid mode. The physical event was held yesterday in Manila, Philippines, and the virtual event is being held through Zoom from 23rd to 24th June 2026. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 8 presentations. Each presenter will be given 12 minutes for the presentation and 3 minutes for question and answers. On 10 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we start the session, I would like to introduce you all to the chair for this session, Dr. Deepika Virari. Dr. Deepika Virari is an assistant professor in Information Technology Department at Army Institute of Technology, Pune. She has total 8 years of teaching experience. Dr. Deepika has published 20 plus research papers in various Scopus Index and UGC approved journals and conferences. Currently, she is associated with research work in different domains like image processing, machine learning, data mining, and artificial intelligence. Now, without further ado, let's start with the first presenter of the day. First, I would like to call upon Ma'am Thaw Thaw Meu to present her paper on the title, A Smart Digital Lock System, Zero Trust Architecture Authentication, and AES for Secure Data Sharing in Maritime Industry. Do we have you here with us, ma'am?
Yes, may I start my presentation?
Yes, ma'am.
Yes.
Wait, I will just stop sharing. You can share your screen.
I can share the screen. Can you see? Can you see my screen?
No, not yet, ma'am.
Can you see my screen? Can you see?
It's not visible, ma'am. Can you please try sharing again?
Yes. Can you see my screen?
No, ma'am.
Yes. Can you see my screen?
Yes, ma'am. It's visible.
Yes, ma'am. Yeah. Yes. And may I start my presentation? And good morning, distinguished guests, respected chairperson and participant. May I introduce myself? My name is Tomeu. And my name is Tomeu. And today I will be presenting my topic on a smart digital lock system for zero trust architecture, authentication, and AES for secure data sharing in maritime industry. Let me go to the next slide. Now I will briefly outline what I will cover in this presentation. The first part is the extra objective introduction. The second part is the zero trust architecture authentication, smart digital lock system, AES-based secure data sharing. The third part is the proposed system, smart digital lock design. So we'll go for proposed smart digital lock authentication, system authentication process, system implementation, and security analysis. And the final part is the conclusions and reference. Moving on to the next slide. As read, a modern maritime industry depends largely on the digital communications and asset control for operational security maintenance. Centralized security measures become the inefficient against modern and advanced cyber threats. In that regard, the system presents the smart digital lock system using the zero trust architecture and AES encryption. The approach is shown for the implementation of zero-trust policy in terms of continuous the user identity validation requiring the tight access control, including the strict user authentications and monitoring. And multi-factor authentications and real-time monitoring are the key characteristics of this system. Communication of authorized party using AES encryption to protect the information privacy and integrity. As a result, the will be assessed from three perspectives: authentication accuracy, data protection effectiveness, and response latency. Objective to design and develop the smart digital lock system based on the zero trust architecture principle, continuous authentication and asset control for maritime environment. To integrate the AES cryptography techniques into this, the proposed system to ensure the secure data sharing and protect sensitive maritime information from unauthorized access, to evaluate the effectiveness in preventing the authorized access attempt, enhancing the data confidentiality compared with the traditional authentication method, to analyze the performance, security, and reliability of the integrated zero trust and AES frameworks, supporting a secure communication and operational efficiency within the maritime industry. Next, I would like to explain the introduction. Maritime industry, one of the key sectors responsible for global economic development and international trade. Over past decade, maritime infrastructure has been undergoing rapid digitization due to the implementation of the new technology. Increased digitization poses numerous cybersecurity threats. Today, cyber criminals exploiting the weak security measure, hacking systems and communication network or maritime infrastructure to access the sensitive information or disrupt operation. In this situation, there is a need for more complex security system would be incorporate the continuous user verification procedure, device protection, and network integrity check. Next, I will go to the next slide. In this slide, I would like to explain the zero trust architecture authentication. The zero trust can be described as never trust, always verify. Traditionally, user and system will authenticate trust by security solution. This approach is effective when addressing contemporary cybersecurity threats. Internally located device and user can post the threat to organizational information. 38 does not presuppose the implicit trust and incorporate continuous verification through the meaning of identity management, least privilege asset control, multi-factor authentication, behavior analytics, and continuous monitoring. The number of advantages are the continuous authentication provided enhancing security or access to resolve with due to the dynamic authentication of user. Secondly, multi-factor authentications are the additional opportunity for verifying the identity of user. It combines the password, biometric, security token, or even mobile verification system. I would like to explain the smart digital lock system. The advent of major innovation increase the telecommuting and the rising adoption of social media and new security threat to business. Employee expect the uninterrupted access to company information anywhere. The problem of accessing systems and its information without authorization, one of the most pressing security problems. Telecommuter and mobile commuting are faced heightened security risks, rely only on usernames and password is inadequate to ensure the security. The cipher lock technology are often pattern authentication service to ensure the asset control, both two-factor and multi-factor authentication through the software-enabled crypto technology. Password or PIN code can be transferred into the one-time authentication code. Next, I would like to explain and continue. Generation of tokenless one-time passwords provide a greater security without requiring modification to any existing password system. Moving to the next point. In this point, I would like to explain the AES-based secure data sharing. AES means advanced encryption standards. There is the symmetric encryption algorithm for reliable and secure encryption for all sensitive information. AES is the powerful cryptographic strength, performance and resistance for brute attack. AES uses the key size of 128-bit, 192-bit, and 256-bit for different security level. AES can be employed in maritime environment to protect the sensitive data and communication log from shipboard and maritime authority. Encryption alone does not guarantee the complete protection for attacker may exploit the vulnerability of authentications and asset control. The combination of AES and zero trust authentication provides a holistic cybersecurity framework for maritime infrastructure. In this slide, there is a proposed system smart digital cloud design. Cipher law techniques include the complete range of authentication techniques, provide the two-factor or multi-factor authentication via a pattern and grid-based software solution. Using the grid technology, Cipher law transforms the one-time passwords different each time at the user log is eliminated need additional hardware or some software component. This approach eliminates the weakness, static passwords without adding any additional element. This technique helps prevent or minimize threat from keylogger, replay attack, shoulder stuffing, automated intrusion, brute force dictionary attack, password sniffing, interception, store browser password, process scripting, and man-in-the-middle attack. There is a pseudocode for proposed smart digital log authentication. Let SGPN stand for the static gripping number, RDGB stand for the respective corner, dynamic gripping or user selected static gripping. The code began for step 1, generate the random number at the corner of the grid. As for step 2, RDGB accept the related dynamic pin linked to the user chosen SGPN, meaning that pre-assigned corner value that correspond to the selected SGPN of static passwords. If RDGB equal to the dynamic gripping associated with the user SGPN, to generate grant the user requested operation message. Otherwise, to generate the entering random gripping does not belong to the random gripping of user pre-selected SGPN, and then go to the step 1, and if. And next, there is a figure or system authentication process. The next slide, I would like to explain the system authentication process. When user logging in, the user see the metric where it consists of static number or symbol in the center and random number in the corner that change with each authentication. User input the number correspond to the pre-selected corner position in place of the associated static passwords character as their one-time passwords. For example, static pin of 245790 and pre-selected corner or top left. The user would input the grid pin or 337447 for this login attempt. Upon adding fresh or new login, the corner number randomly changes, creating the new one-time passwords. The single cell with number in the corner that change with every login are the foundation or cipher log pattern software based grid that are used to convert the static password into secure one-time passwords. And in this slide, I would like to explain the system implementation and security analysis. The system is designed to enhance both physical asset control and digital communication security within the maritime environment, such as the smart port, vessel, and restricted operational facility. The implementation focus on encryption mechanism, secure communication process, system, workflow design, hardware or software configuration, threat modeling and attack scenario, and comprehensive security evaluation based on the confidentiality, integrity, and availability. Due to the time constraints, I will skip the detailed explanation as already covered in the paper. In this slide, finally, I would like to conclude my presentation. Smart digital law combines the cipher law with AES, strengthen cybersecurity in maritime operation, improve the asset control method, ensure the secure and reliable information flow and storage. Security review combinations of such method protecting the information from major cyber threat. Issue the scalability and flexibility and import and confessor in the digital era. Based on the finding, this approach concludes that appropriate security approach involving authentications and encryption reliable tool for securing the crucial maritime system. There is a reference of my system, and thank you for your attention. If you have any question, I will happy to answer them.
Thank you for your presentation, ma'am. Next, I would like to call upon Ma'am A. Marla Wind to present her paper on the title ECG beat classification based on wavelet attention mechanism. Do we have you here with us, ma'am?
Yeah.
Yes, I'm here.
Okay, ma'am. You may start sharing your screen, ma'am.
Okay. Can you see my sharing screen?
Yes, ma'am. Your screen is visible.
Good morning, respected chairperson, ladies and gentlemen, and fellow participants. And I'm Imalawin from University of Computer Studies, Yangon. Thank you for giving me the opportunity to present our work entitled ECGP classification based on wavelength attention mechanism. During this presentation, I will briefly introduce the research problem, explain the proposed approach, and discuss the experimental results and conclusion. Let me move to next slide.
Yes, ma'am.
This slide is outline of my presentations. Let me move to next slide.
Yes, ma'am. You may continue the presentation.
Yes. This slide is a strand of my presentation. The classifications of the electrocardiogram signal has a vital impact on the identifications of heart conditions and related disease. ECG classifications involves analyzing electrocardiogram signals to automatically identify different types of heartbeats or cardiac condition. Classifications on ECG includes normal, supraventricular, ventricular fusion, and noisy or unknown beats on MIPID datasets. In pre-processing, bandpass filtering and min-max normalization is applied and segmentations around are built. Then extra features using wavelet, discrete wavelet transform and tray modeled with CNN sub-attention. Single lead, multi-lead, lead fusions, and feature fusion approaches are analyzed on MIPID dataset. Let me move to next slide. This slide is introductions of my presentations. ECG signals are learning the ECG patterns directly from raw signals and scaling to millions of beats and thousands of patients. Many hacker system labs in accurate ECG data. Manual ECG analysis is time-consuming and potential false error. The automated ECG detection and classification system is intended to develop. ECG signals are based on single lead, multi-lead options. Let me move to next slide. Signal is robust for classification based on various lead configurations records. A multi-scale discrete wavelet transform is decomposing signal into different frequency components at multiple scale. These decomposed signals are selectively focused on the most relevant parts of the wavelet decompositions and improving feature representations. Then ECG classification for signals are processed based on CNN attention. Let me move to next slide. This slide is motivations of my presentations. The global burden on health issues with heart conditions. The electrocardiogram has long been a popular tool for assessing and diagnosing cardiovascular diseases. Deep learning captures complex patterns. Let me move to next slide. This slide is objectives of my presentation. First is to classify the categories of heartbeats using electrocardiogram data. Second is to be more accurate in identifying and classifying the individual's heartbeat and types of ECG. Third is to implement the multi-scale wavelet attentions for ECG detections and classification bit CNN attentions. And fourth is to develop ECG classifications on MIPID dataset. Let me move to next slide. This slide is problem statements of my presentations. ECG waveforms vary significantly between individuals and conditions. Morphological variations across individuals causes misclassification. ECG signals vary in durations, leads, and sampling frequencies, and datasets include imbalanced class. Let me move to next slide. This slide is contributions of my presentations. Is to investigate on various bit and segmentations with wavelets and analyze single leads, multi-leads, lead fusions, and feature fusions on MIPID datasets. Multi-scale wavelet CNN attention with the class wave balancing is implemented, and the multi-scale wavelet CNN attention is compared to multi-scale wavelet CNN. Let me move to next slide. This slide is data set in this study. MIPID arrhythmia is band-matched data set with 30 minutes long and 42 records and sampling rate 360 Hz. Data source is described. Let me move to next slide. This slide is MIPID arrhythmia database class level. According to AMI class levels, Table 1 describes the classes in MIPID arrhythmia database. Let me move to next slide. This slide shows Table 2 shows the numbers of beats in this study. Let me move to next slide. In this study, MIPID dataset was divided into training, validations, and testing sets. Specifically, 70% of the data was allocated for training, while 50% was used for testing, and the remaining 50% for validation. This approach helps assess the model's performance on assigned data. Let me move to next slide. This slide is system flow. This diagram illustrates the overall system flows of the proposed methodology. The input ECG signals undergoes preprocessing. In preprocessing, remove noise and improve signal quality using bandpass filtering and normalization. ECG signal is divided into phase length segment around a bit. Then wavelet feature extraction is performed on each segment to capture signal characteristic. Relevant features are extracted and prepared for model input. Then save trace CNS attention model, and the process data is then fed into the classifications model where the ECG bits are analyzed and categorized into their respective classes. Finally, the model generates the ECG classification result, which are evaluated using performance metrics. Let me move to next slide. This slide describes the preprocessing. In preprocessing, a bandpass filter is used to filter out unwanted frequencies from signals, improving the quality and fidelity of the desired signals. Lower cut-off frequency is 0.5 Hz and upper cut-off frequency is 40 Hz. Normalization. Through subtraction of the minimum and deviation behind the range min-max normalization, rescale all values to a fixed intervals. Let me move to next slide. This slide describes the segmentation. The individual Cardi cycle is by centering segmentation windows around RPs, which represents the most prominent components of the 2RS complex. P segment equal to thickness of Ri minus FR to Ri plus beta Ri represents the positions of the ith RPs. The segmented heartbeat window where FR and beta denotes the numbers of samples before and after the RP. Figure 2 shows the segment of a beat. Let me move to next slide. This slide is Whiffler feature extractions. Whiffler feature extraction using TIBS system Whiffler transform with the following steps. Threshold equal to sigma of coefficients finite into square root of 2 into log of length of signal. Wherever sigma represents the operator of standard deviation, coefficient finite represents the finite coefficients, and element length and H is the signal. Let me move to next slide. This slide is CNN sub-attention model architecture. The slide presents the architectures of the proposed model, and the model receives the extracted feature as input and process them through multiple layers to learn meaningful patterns from the signal. Each layer plays a specific role in feature representation, learning, and classification. Finally, the output layer generates the classification results for each ECG segment. Let me move to next slide. This slide is accuracies and precisions of performance metric. Let me move to next slide. This slide describes the records and advanced scores of performance metric. Let me move to next slide. In this slide, lead fusion techniques improves accuracy.
Ma'am, this is a gentle reminder that we have crossed the 10-minute mark. You may conclude your presentation in the next 2 minutes.
Yes. Yes. Technique improves accuracy on each class in model-based singly, multi-lily fusions, and feature fusion approaches. Let me move to next slide. This slide describes using singly, multi-lily fusions, and feature fusion. Figure 5 shows the average performance values of 5 classes on precision record and advanced score. Let me move to next slide. This slide shows the average results or accuracies based on lead fusion with CNN sub-attention and CNN model. In this stereo fusion, normal and ventricular beats are more accurately classified in lead fusion with CNN sub-attention. Let me move to next slide. This slide is conclusion of my presentation. Multi-scale wavelet attention and CNN attention is implemented to enhance beat detections and ECC classification. This theory is only on feature-based window segment and singly, multi-lily fusion and feature fusion on mid-bit dataset. Let me move to next slide. Thank you for your attention. Please feel free to ask questions.
Thank you for your presentation, ma'am. Do we have any questions? Since there are no questions, we'll be moving forward with the next presenter. Next, I would like to call upon Ma'am Caroline Sutiono to present her paper on the title Enhancing User Experience Through Technology Acceptance and Server Efficiency.
Let me start my sharing screen.
Sure, ma'am. Right. Next, I would like to call upon Ma'am Caroline Sutiono to present her paper on the title Enhancing User Experience Through Technology Acceptance and Server Efficiency, a service design perspective in O2O F&B retail. Do we have you here with us, ma'am?
Yes.
Okay. You may present your screen, ma'am.
So can you see my screen now?
Yes, ma'am.
Good morning, good afternoon, or good night, Citizen Chairs Committee and all authors and audience. So my name is Caroline Sutiono from Hotel Management from Buenos University. So allow me to explain our paper is about enhancing user experience to a digital acceptance and service efficiency, a service design perspective in the O2O F&B retail. So this is my contributor member. There's me, Caroline Sutiono, Ronald Gunawan, Silvina Chandra, and also Maria Pia Adiat. So before discussing of our research, so it is important for us to understand the concept of O2 online application. So online to application is digital platforms developed by companies to integrate online service with online business operations. So in the context of food and beverage industry, so these applications are often amplified as the super application that enable customer to browse product, place an order, and make payments and access various service through their smartphone. The primary purpose of O2 application is to provide convenience and accessibility, allowing customers to order products anytime and anywhere while enhancing overall user experience. And before moving on, the main discussion of our study is it important to understand how O2O application works. First, customer use the mobile application to browse menus and view price and promotion, and customize the order and place the orders. So they can choose either self-pickup, online delivery, or other option that's available. So once the order is submitted, so the online to application platform is automatically transfer the order information to the restaurant or the cafe POS. And this enables staff to receive and process order in real time. And after the order is prepared, the customer receive their products through the selected method, either self-pickup or delivery. And this integration is create a convenient and efficiency and seamless and customer experience. And this research was motivated by a gap identified in the previous study of the O2O application. And most research types primarily focus on the variables such as application features and promotional strategies and customer purchase intention. While this study is provide more available insight, they tend to emphasize the functional aspect of application rather than the actual experience perceived by the customer during their interaction with the platform. To address this gap, so our study shift focus towards the customer experience integrate perspective from technology acceptance model and service design. Specifically, we aimed to examine how the perceive of use and also perceive of use together with the service efficiency influence the overall experience in the auto application within the food and beverage industry. And this study is built upon the 4 key concepts. So first is online to offline application. The second is the technology acceptance model. And then third one is service design. And the last one is the customer experience. So online to offline application are digital platform that enable customers to online order products anytime and anywhere, as I said before, through their smartphone. So this application is integrate online ordering with the offline fulfillment. So allowing customer to browse product as customized and make digital payment before receiving their products at the physical outlet. So the seamless integration and digital physical appearance enhance the convenience, service efficiency, and overall customer experience. Next, on the technology acceptance model, so this is developed by Davis in 1989, and then explain how user adopt and utilize new information technology across various industry, including in the food and beverage sector. So in the context of O2O application, so perceive of use model is refers at the application ability to improve service efficiency and also convenience, while the perceive of ease of use refers as the degree of which the application is easy and effortless use through this user-friendly features and smooth navigation. While service design refers to planning and organization both tangible and intangible service elements to create an accessible and also enjoyable user experience. So in a critical dimension in the service efficiency, which emphasizes speed of delivery, accuracy of order processing, and also overall service quality. So technology play a significant role in enhancing service efficiency and also operational performance. Lastly, customer experience and omnichannel ecosystem is shaped by entire customer journey from a digital interaction such as app usage and product search to physical experience such as a product pickup and service equality. And also customer experience in omnichannel refers to customers perception of their overall shopping journey across integrated channels, and then keys of value, a personalization, consistency, and also loyalty programs, which enhance the satisfaction and also the loyalty. We move on the research methodology. So we use a quantitative research approach, and the target of the population is Indonesian customer who have used the O2O application in the F&B sector. The sample of the size, we use a hair formula theory, which is times 10. So we have 15 indicators. So the minimum sample is required is 150 respondent, and we managed to get 160 respondent. And the data collection is online questionnaire distributed online via Google Form and through social media platform, like measuring Likert scale 1 to 5 and ranging from strongly disagree to strongly agree. So the data analysis using our partial least square structural equation modeling, or PLSM method, that with the help of software small as PLS4, because it is designed to analyze a model within many indicators. And then next on the results, so because this study is already collecting 160 respondents, which is satisfied the minimum sample requirement. And then the sample was dominated by female respondent, and more than half of the respondents were aged between 21 to 25. So and students consist of large occupation group at 55.6%. And most of the respondent also report a monthly income between 1 to 5 million Indonesian rupiah, which has already used the application between 1 to 3 times. And also the overall of the sample is mainly consists of young adult student who active user of the application. So this slide is present the measurement model assessment. So first, the conversion fidelity and all the indicators are achieve auto loading values and above the recommended threshold of 0.70. So this indicate that each indicators have adequately represent its respective construct. So second, so we evaluate the reliability and also validity of the measurement model. So this results show that all the Cronbach alpha and also composite reliability values exceed 0.70, which is confirming internal consistency reliability. In addition of LV values are about 0.50, so indicating all the satisfactory are convergent of validity. So therefore, we can conclude that all the structures in the study are both reliable and valid, allowing us to proceed with the hypothesis testing. So in the hypothesis testing results show that 2 of the 3 proposed hypotheses were supported, and based on the testing result indicate only 2. So the effect of perceived of usefulness on customer experience have a t-statistic of 3.005, so it's greater than 1.96. So it's a p-value of 0.003, so it's less than 0.05. So it can conclude that the perceived of usefulness has a significant effect on the customer experience. And the effect of perceived of use on customer experience have a t-statistic of 4.870, so it's greater than 1.796. So it's a p-value of 0.000, so it's less than 0.5. So it can conclude that the perceived of ease of use has a significant effect of the customer experience, while the effect of service efficiency on the customer experience have a t-statistic of 1.797, so it's less than 1.96. So it has a p-value of 0.04, 0.072, so it's less than 0.05. So it's therefore that it can be concluded that service efficiency does not affect the customer experience. And based on the finding of the study, so several important conclusions can be drawn. First, the perceived of use as emerged as the strongest predictor of customer experience. So this finding suggests that the customer places a high value on applications that are intuitive, convenient, easy to navigate. And also in the context of O2O application, users are expected as a seamless ordering process, so clear menu navigation, and also a simple payment system. So when these features are easy to understand of use, customers are more likely to report a positive overall experience within the application. Second, we have a surface efficiency was not found to be a statistically significant effect on the customer experience, although surface efficiency remain important from a operational perspective. So the result indicate customer may not directly evaluate their experience based on backend operational performance. Instead, user appears to more focus on how interact with the application itself. This finding also may be influenced by the demographic of profile of the respondent, where majority of young adults between age 21 to 25 years old who are generally familiar with the digital technologies tend to prioritize convenience and also usability. And furthermore, this finding highlight the success of the auto application depends not only on the operational performance, but also the ability of the technology to deliver a seamless and useful and also a meaningful experience. So in the other words, in the business should not focus on solely on improving the service efficiency behind the scene, but also to invest in creating user-friendly interface, clear functionalities, and also smooth digital interaction that enhance the customer engagement and satisfaction. And finally, future studies may consider incorporating digital literacy as a moderating variable, since users have a different levels of technology competence, and digital literacy may influence how customer perceive usefulness and ease of use of the application. So examining this factor could provide a different understanding of the customer behavior and also technology acceptance across different user groups. So overall of this study demonstrate that a customer experience are more likely to influence the quality of their digital experience than by the service efficiency alone. So therefore, creating useful, intuitive, and user-centered application maybe is essential for enhancing customer experience in the O2O environment. So this is our author contribution, and this dataset will be available at Zendo. And this 3 slide is the reference that we use for this paper. And thank you for your time, ladies and gentlemen.
Thank you for your presentation, ma'am. Do we have any questions?
No questions from my side.
Okay, ma'am. Since there are no questions, we'll be moving forward with the next presenter. Could you please stop sharing, ma'am? Next, I would like to call upon Ma'am Sue Tet Wu to present her paper on the title Fine-Tuning CNN-Based Detection of Real versus AI-Generated Artwork Images. Do we have you here with us, ma'am?
Yes, I'm ready.
Yes, ma'am.
So can you see my my PowerPoint?
Yes, ma'am. Your screen is visible.
Good morning, Your Highness, Excellencies, and delegated participants. I'm very honored to be here today, and thank you very much for giving me the opportunities of attending this conference of TIBS 2026. So my name is Sutta Wu. I'm a PhD candidate doing research in University of Community Study Rangoon, Myanmar. So I'd like to give a presentation on the title of fine-tuning CNN-based detection of real versus AI-generated artwork image. So these all points will be included throughout my presentation. So may I start here? As an abstract, a fine-tuned CNN-based generated art detection system is an empirical state to accurately classify real and human-created art, allowing discriminated visual features. So in this instance, a pre-training CNN model, fine-tuning architectural layers, and defining the spatial dimensions is included to determine detail capture in feature extraction and classification. and also a base net of VGG16 in traditional architecture, and this architecture of high-tone VGG16 was trained and evaluated. Uses the balanced data set of real and AI-generated art images. So it is found that hyperparameter tunings of task perspective improve representation, data augmentation, and layer optimization strategies can result benchmark against a strong baseline. So I'd like to continue the introduction part of our system. The automatic detection of AI-generated art images are very important for authenticity verifications, provenance control, misinformation management, and digital forensics. So, because the deep learning content generations are rapidly evolving, and the existing detection approach in artistic imagery remain on the explorer domain. The artworks may differ widely in styles, and it often contains non-standard, complex, or distorted visual patterns. Another point is that advanced models such as GANs, generated adversarial network, and diffusion-based model are significantly changing the process of artistic creations. So it is growing concern about the integrity, creativity, uniqueness, and attribution of the origin. This we require for automatic systems that can capable of distinguishing between human-made artwork and machine-generated images. So our study proposed a scenario-based approach called 5G VGG16 architecture that can classify real and AI-generated artwork by learning discriminative visual features such as texture, structure, and statistical patterns. The model incorporates layer optimization, hyperparameter tuning, spatial dimensions adjustment, and data augmentation techniques to improve feature extraction and classification performance. So by conducting the experiments on the proportional repository of authentic and synthetic visual, we also make the comparisons between the traditional VGG16 architecture and the proposed Python VGG16 model. The results are benchmarked against the strong baseline by evaluating transfer learning parameter refinement strategy for generated art detection. So the system used the VGG16 traditional learning classifier as a fixed feature extractor, and it is compared with the 5-tuning VGG16s and ability to adapt retrained features to the target domain. To assess this domain-specific adaptation of real or AI-generated artwork, the input data sets, the input image size was adjusted. And we also make freezing the early convolutional layers, and but the deeper convolutional layer were unfrozen, and binary classification was added for custom fully connected layers. So this kind of strategy ensures the fidelity of the model prediction in a clean, robust, and scalable pipeline to address the identifications of real and AI-generated artwork. So I'd like to continue about the data set that is used in our system. It is a balanced data set consisting of real artwork. The real artwork are sourced from the Wikid art repository, and fake images are from GANs and AI models. And it is also a combined total pair of 2,000 images, which means 1,000 for authentic artwork and 1,000 for fake artwork is applied in our system. So it was employed from the front Friday data sets, providing over 21,000 professionality distributed images, and it was publicly available on the Kaggle data. The representative sample images are illustrated in Figure 1. So Figure 1 is the sampled art images from the dataset showing the two classes of real and AI art images. And in Table 1, we can see that dataset analysis of dataset distributions of art images. So it contained a pair of 2,000 real and AI generated images. So total is 4,000 images diffused. All these data were distributed across three subsets, 80% for training, so 3,200 of total images, where 1,600 for each real and AI generated images. And 10% of images, so 200 real and 200 AI, total of 400 images are used for validation. And similarly, 10% of images are used for independent testing. So we also do the deep data preprocessing steps, including image resizes to 256 to 256 to 3 spatial dimension, elimination duplicate sample, and balancing what class distributions between real and AI generated images. And we also use the data augmentation techniques such as resizing, flipping, rotating, brightening, and noisy techniques were applied for all the models during training to enhance model robustness and simulate real or artistic variant. So figure 2 is the pre-processing image sample for augmentation outcome. So I would like to continue about the transfer learning concept for the art image. The VGG16 net is the pre-trained model that have already captured fundamental visual patterns such as edges, gradient, and textures. This pre-trained model can be effectively reused across other various domains. So in this system, we use this pre-trained model with our relatively small task-specific data set of AI-generated and real art image. And another point is that 224 to 224 to 3 pixel is the standardized input resolution size for VGG16 architectures that was trained on ImageNet. So when we use our task-specific transfer learning art image dataset is learn, these kinds of spatial dimensions will resource the loss of artistic details such as fine textures and individual fractures. So to fine-tune these pre-training models, when we use target-specific images, all the image input images were resized to 256 to 256 to 3 spatial dimension. So it is the VGG16 transitional model architecture. So this is the this architecture is the multi-layer process that involves convolutional layer, pooling, and fully connected layers. All convolutional layer drive picture map by performing element-wise multiplications between kernel of 3 to 3 and input size, uses the related activations and the same pattern. And fully layer can extract the most important information from this visual map and provide it as an input to the next convolutional layer. So in this transitional model architecture, the initial convolutional block that have two convolutional layers to detect sample patterns, and the latter blocks that have 3 different convolutional layers to recognize complex artistic and semantic features. The final layer is the fully connected layers. Fully connected layer to flatten the input image into one-dimensional vector of real or AI-generated output image, passes them through dense layer of 4,096 units using the softmax activation function. I would like to move to the next slide. Yes, figure 4 is the 5-June VGG16 architecture. So in this architecture, the convolutional base of VGG16 is initialized using the pre-trained image weight obtained from the prior training on the millions of natural images. So during 5 units, the majority of all convolutional layer
It's a gentle
process.
reminder that you have crossed the 10-minute mark.
Sorry.
This is a gentle reminder that you have crossed the 10-minute mark. Kindly conclude the presentation in the next 2 minutes.
Yes, I'd like to continue my presentation. During 5 units, the majority of early convolutional layer are frozen to preserve general feature expression capability, while the final convolutional layer were frozen to retain using the artwork datasets. So this pre-trained layer already contains generalized visual representation. So instead of learning all features from the beginning, the 5G model can reuse the existing visual knowledge and adapt it specifically to the real and AI-generated art classification tasks. So I'd like to continue about the experimental results. Table 2 is the experiment result for both VGG16 and 5G VGG16 image detection models with the specific metric of training, validation, and training, validation, and testing accuracy and loss, and other specific metric. So with respect to the efficiency, the experiment results show that 5G model can yield 96% of text accuracy, while the base model exhibits 83%. It is a lower degree of inferential resilience compared to the hyperparameter 5G model. So in figure 5, we can see the visualization results of the proposed VGG16 models, yielding the training accuracy of 98% and 95% of the validation accuracy. So it demonstrated the model can learn the effectively sequential patterns from the data sets, and the model also indicate achieving convergence with the training error of 0.04 and the corresponding validation loss of 0.14. So it shows that it has a stable and smooth convergence and does not overfit significantly with a batch size of 32 and 30 apples. So however, in figure 6, we can see the base model, which suffer from the highlight and fluctuations with a higher validation error. So figure 6 is the analysis of training and validation accuracy and loss of traditional VDD16 architecture. So I would like to conclude my presentation. So this is the conclusion part of our system. So it is an empirical study using the CNN-based functional VDD16 model that can effectively distinguish between AI-generated artwork and authentic human-created art. The system used the dataset preparation, preprocessing model, reprocessing techniques, and which is transferred to learn the specific art image tags and fine-tune the proposed architecture. So applying transfer learning, hyperparameter units, layer optimization, and data augmentation, the model can learn important visual features. The experimental results on the balanced dataset show an accuracy performance of 96% when compared with the traditional VDG16 architecture, which has lower achievement of 0.83% of text accuracy. The finding highlight that the latent capabilities of multi-layer convolutional models for generated art detection, and it can also contribute to the applications in digital forensics, authenticity verifications, and misinformation control. For future work, our study will use larger and more diverse datasets, including artwork generated by emerging AI models. Then it will also focus on clear, interpretable, and principled decision-making in practical applications of artistic provenance verification and computational forensics. So these all that I did references throughout my study. Thank you very much. Thank you for your time.
Thank you for your presentation, ma'am. Do we have any question? Since there are no questions, we'll move forward with the next presenter. Now I would like to call upon Ma'am Gairli Raza DS Reyes to present a paper on the title Intelligent Transformation of On-the-Job Training in Philippine Higher Education, a systematic literature review through the lens of artificial intelligence, data analytics, and digital strategy. Do we have you here with us, ma'am?
Yes, hello, good morning.
Yes, ma'am.
Let me share my screen.
Yes, ma'am.
Can you please remove your share screen, Miss the last presenter? Okay, thank you. All right, can you see my screen?
Yes, ma'am.
Okay, thank you. So good day, everyone. I'm Girly Riza de los Santos Reyes from Philippines, together with my co-author, Professor Ferdinand V. Dalisay. So we're talking about our study is all about intelligent transformation of on-the-job training in Philippine higher education. Okay, OJT has always served as the bridge between classroom learning and workplace. However, the world of work has changed dramatically. Today's industries expect graduates who are digitally competent, adaptable, and capable of working alongside with AI technologies. Despite this, many OJT programs continue to rely on traditional administrative processes. Our review identified 4 persistent challenges. First, the curriculum, industry misalignment, where academic and preparation no longer reflects current industry needs. Second is the limited supervision due to increasing number of students and geographically dispersed placements. Third is the weak quality assurance caused by manual monitoring and inconsistent evaluation. And finally, the fourth one is the equal access to quality industry partners, especially among provincial institutions. These issues demonstrate why incremental improvements are no longer sufficient. The fourth industrial revolution, or the 4.0, is fundamentally transforming higher education. Artificial intelligence, or AI, automates routine tasks while supporting personalized learning. Data analytics converts educational data into meaningful insights for decision making. Digital transformation goes beyond technology. It changes institutional processes and organizations. When these three forces converge, they create what we call on the digital OJT ecosystem, where students, universities, and industry partners collaborate through integrated digital platforms. This systematic review sought to answer four major questions. First, how is artificial intelligence currently being integrated into OJT supervision and mentoring? Second, how can learning analytics improve quality assurance and evidence-based management? Third, what is the current level of adoption of digital platforms supporting OJT? And finally, the fourth question is, do existing OJT programs adequately prepare students for the demands of the digital economy? And together, these objectives provide a comprehensive view of the future direction of OJT. We adopted a systematic literature review, or SLR methodology, to ensure transparency, rigor, and reproducibility. We search multiple international databases, including Scopus, Web of Science, IEEE Explore, ACM, Springer, etc. Initially, we identified 412 publications. After applying inclusions and execution criteria, conducting quality appraisal, and removing duplicates, only 35 high quality studies were included. These studies formed the evidence base on our review. To organize the findings, we developed a four-dimensional analytic framework. At the center of the of course, is the intelligent OJT. Supporting this concept are four interconnected dimensions. Artificial intelligence enhances supervision and competency assessment. Data analytics supports monitoring and quality assurance. Digital platform connects stakeholders in real time. And finally, the digital strategy aligns institutional initiatives with national workforce priorities. These four dimensions collectively define an intelligent work integrated learning ecosystem. Our first major theme focuses on artificial intelligence. AI has the potential to transform supervision from occasional monitoring into continuous monitoring. So technologies such as intelligent tutoring system can provide personalized guidance. Natural language processing, or NLP, can analyze students' reflective journals. Machine learning can predict students who may need additional support, and the computer vision may even assist in remote practical assessments. Overall, AI enables more personalized, scalable, and evidence-based supervision. Despite AI's potential, our review revealed significant disparities across institutions. Metro Manila, here in the Philippines, the universities in Metro Manila generally exhibit stronger digital infrastructure, analytics capability, and AI readiness. Provincial institutions continue to experience limitation in funding, connectivity, and infrastructure, and technical expertise. This digital divide suggests that successful AI implementation requires differentiated policies rather than a one-size-fits-all approach. The second theme centers on learning analytics and business intelligence. Currently, most OJT information remains fragmented across logbooks, evaluation forms, and spreadsheets. So, by applying predictive analytics, institutions can identify struggling students earlier. Benchmarking enables comparison across programs, early warning, system support timely interventions. Ultimately, the analytics shifts OJT management from intuition towards evidence-based decision-making. The technology alone cannot transform OJT. So effective government is equally important. Our proposed framework consists of 4 levels. National agencies such as the CHED or the Commission on Higher Education provide policies and standards. Sectoral organization defines industry competencies. Universities implement institutional strategies. And finally, the operational team execute day-to-day supervision and monitoring. So alignment across these levels ensures consistent and sustainable implementation. One of the strongest findings of our review is the need for an integrated digital platform. Rather than using disconnected system, all stakeholders should interact through a single ecosystem. Students submit digital logbooks. Supervisors provide online evaluations. So AI supports placement matching. Administrators monitors institutional performance through dashboard. Such integration improves communication, transparency, efficiency, and throughout the OGT lifecycle. If you remember, the COVID-19 pandemic accelerated the adoption of virtual OJT, what began as an emergency response that has now become a permanent um, educational option. So virtual placements increase flexibility and broaden access to industry opportunities. However, challenges remain. So reliable internet connection, adequate devices, and digital literacy are still unevenly distributed. So therefore, virtual OJT should complement rather than completely replace traditional workplace experience. Our final theme examines whether OJT prepares a student for today's digital economy. We identified 3 competency levels. The digital foundation skills are moderately developed. Digital professional competencies remain limited. Digital leadership competencies are largely absent. This competency gap suggests that OJT curricula must evolve into include AI literacy, data analysis, the digital collaboration, and technology-enabled decision-making. To summarize our findings, AI adoption remains limited. Data systems remain fragmented. Digital platforms are emerging but lack interoperability. And mostly, OJT programs are still not fully aligned with the digital workforce expectations. So these findings highlight that transformation requires both technological innovation and institutional reform. So on our synthesis, we propose a phase roadmap extending from 2026 onwards. So initially, institutions should pilot AI dashboards and standard data collection. So the next phase focuses on developing a national digital OJT platform. The third phase introduces industry co-designed competency framework. And ultimately, the goal is to fully integrate AI-driven national OJT ecosystem supporting continuous quality improvement. Our recommendation target four stakeholders groups: CHED, the Commission on Higher Education in the Philippines, should establish national AI policy and standardized analytic frameworks. Universities, or the HEIs, higher education institutions, should invest in digital infrastructure and faculty capability development. Industry partners should actively participate in competency framework design and expand digital placement opportunities. Researchers should continue investigating AI ethics, learning analytics, and long-term OGT outcomes. So transformation requires collaboration among all these stakeholders. In conclusion, OJT must evolve from traditional administrative requirement into an intelligent learning ecosystem. AI should support and not replace human mentorship. Data analytics should drive continuous quality improvement. Digital platforms should connect universities, students, and industry in real time. And if implemented strategically, this innovation can better prepare Filipino graduates for the demands of the digital economy and the future of work. So that concludes my presentation. Thank you very much for your attention. We welcome your questions, comments, and suggestions. Thank you, and we look forward.
Thank you for your presentation, ma'am. Do we have any questions? Since there are no questions, we'll move forward with the next presenter. Next, I would like to call upon Sir Jansen Emmanuel Jahaja to present his paper on the title, The Impact of Virtual Try-On Technology on Consumer Buying Impulse and Purchase Behavior. Do we have you here with us, sir?
Yes.
All right, sir. You may present your screen, sir.
Let me check the camera first. Okay. All right. All right. Good morning, everyone. My name is Jensen Emmanuel Jahya from Binus University, Indonesia. Today, I'm honored to present my research entitled The Impact of Virtual Try-On Technology on Consumer Buying Impulse and Purchase Behavior. This study focused on understanding how technological and psychological factors influence consumer attitude toward virtual try-on technology and how this attitude ultimately affect online purchasing intention. As e-commerce continues to grow worldwide, understanding the role innovative technology such as virtual try-on become increasingly important for both research and practitioners. Now, let us begin with the background of this study. So this is the table of content. And on the introduction, the growth of e-commerce has transformed the way consumer shop and interact with product. Today, consumer can purchase product anytime and anywhere through digital platform. However, despite this advantage, online shopping still presents several challenges. One of the most significant challenges is that inability to physically examine or try product before making a purchase decision. This limitation often create uncertainty regarding product sustainability, quality, and appearance. To address this issue, many online retailers have begun implementing virtual try-on technology. Virtual try-on utilize augmented reality technology to allow consumers to visualize and virtual try product before purchasing the product. This technology is expected to improve consumer confidence, reduce perceived risk, and create more engaging shopping experience. Therefore, understanding the factor of encourage consumer to adopt virtual try-on technology as an important research topic. And the problem, this research is based on three key problems. First, online shopping limits consumer ability to evaluate product directly before purchase. Unlike traditional shopping, consumer cannot physically inspect product, which may increase uncertainty and hesitation. And second, uncertainty regarding whether a product will fit consumer expectation may negatively affect purchase decision and reduce purchasing confidence. Third, although virtual try-on technology has become increasingly popular, previous studies have not fully explained how technological and psychological factor is influencing its adoption and usage. Therefore, this study attempts to fill this research gap by examining both dimension and science simultaneously. And research objective. Based on this problem, the study has three primary objectives. The first objective is to identify the factors that influence consumer attitude toward virtual try-on technology. The second objective is to examine how technology and psychological factors contribute to adoption virtual try-on. The third objective is to analyze how consumer attitude toward virtual try-on influence online purchasing intention. By achieving this objective, the study aims to provide insight that can help commerce business design more effective virtual try-on experience. And the research framework, this study adopted the technological acceptance models, or we can say TAM, as the theoretical foundation. Several technology factors are included in the model. These factors are perceived ease of use, which is referred to how easy to technologically to use, perceived usefulness, and which measured how beneficial a consumer perceives the technology to be, and perceived enjoyment, which is reflect the level enjoyment experienced while using the technology. In addition, two physiological factors are included: self-efficacy and personal innovativeness in information technology. These variables are expected to influence consumer attitudes toward virtual try-on technology. Subsequently, consumer attitudes are expected to affect online purchase intention. Overall, 9 hypotheses were developed and tested. The methodology, this research employed a quantitative research method, research approach. Data were collected using an online questionnaire distributed to respondents who had experience with online shopping and were familiar with virtual try-on technology. The questionnaire measured out construct using multiple indicator adapted from previous studies. A total of 324 valid response were collected and analyzed. For the data analysis, this study utilized partial least square structural equation modeling, or PLSM. You can say PLSM was selected because it's highly suitable for examining complex relationship among multiple latent variable and testing theoretical models. The analysis was conducted to evaluate both measurement validity and structural relationship among variables. This is the respondent profile. The slide presents the demographic characteristic of the respondent. A total of 324 respondents participate in this study. Regarding gender distribution, 51.54% of respondents were female, and while 48.46% were male. In terms of age, the majority of the respondents were between 70 and 45 years old. This age group represents the most active segment of e-commerce user and digital technology adopt. Furthermore, the respondents came from diverse educational and occupational background, which is enhanced the representative of the sample. Therefore, the respondent profile aligned well with the target population of virtual try-on user. And hypothesis testing result. The result of hypothesis testing demonstrates strong support of the proposed model. All 9 hypotheses were accepted. Each relationship achieved statistical significance with a p-value below 0.05. For example, perceived ease of use of significantly influence both perceived usefulness and consumer attitude. Similar, perceived enjoyment and perceived usefulness significantly contribute to positive attitude toward virtual try-on technology. Psychological factor, including self-efficacy and personal innovation in IT, also show significantly positive effect on online purchase intention. This finding confirms that both technological and psychological aspects are essential in encouraging consumer acceptance of virtual try-on technologies. And there are 3 major findings from this research. First, technological factors play a critical role in shaping consumer attitude. Consumers are more likely to adopt virtual try-on technology when it is too easy. When it is easy to use, useful, and enjoyable. Second, psychological factors significantly influence consumer willingness to engage with innovative technology. Individuals who are confident in using technology and are open to technological innovation demonstrate stronger purchase intention. Third, consumer attitude serve an important mediator between technological perception and purchasing behavior. This means that improving consumer attitude toward virtual try-on can ultimately lead to a stronger purchase intention. So in the conclusion, this study provides empirical evidence that both technological and psychological factors significantly influence consumer behavior towards virtual try-on technology. Perceived ease of use, perceived usefulness, and perceived enjoyment positively affect consumer attitude. Meanwhile, self-efficacy and personal innovation positively influence online purchase intention. Additional positive attitude toward virtual try-on technology significantly increase consumer intention to purchase product online. These findings suggest e-commerce companies should invest in user-friendly, enjoyable, and innovative virtual try-on experience to improve customer engagement and encourage purchasing behavior. From an academic perspective, this study also extends a technology acceptance model by integrating a psychological factor into the analysis of virtual try-on adoption. So that's the conclusion. This concludes my presentation. Thank you very much for your attention. I hope the research provide valuable insight, consumer behavior, and the growing role of virtual try-on technology in commerce. I would like to answer any question or discuss the finding now. Thank you.
Very good presentation. I have just one question. What challenges you were faced, and what are the drawbacks of your current system of virtually try-on application?
Sorry, I can hear a lot. I can hear a question. Can you repeat the question? Sorry.
The question is that what are the challenges you were faced while implementing, and what are the drawbacks of your virtual trial-on system?
The challenge. the challenge of the steps. So maybe and back to the objective. For me, the challenge for the research is that we can that I can find the result why people want to use virtual try on online purchasing and uh why virtual try on is effect on purchasing behavior and purchase online purchase intention can increasingly on impulsive buying.
Okay, okay. Thank
Is
you.
it
Thank you so much.
okay?
Thank you for your presentation, sir.
Okay.
Now I would like to call upon Sir Krishna Kanwar to present his paper on the title Wealth Bridge, a hybrid deep learning framework for personalized financial risk profiling and portfolio allocation for the sandwich generation. Do we have you here with us, sir?
Yeah, I'm here.
Right. You may present your
Let
screen,
me
sir.
yes. Can you see it?
Not yet, sir.
Not yet.
It's visible now.
All right. So good afternoon, everyone. My name is Krishna Kanwar. I'm a student of Manipal University, Jaipur, and today I would like to present to you my paper titled Wealth Bridge, Hybrid Deep Learning Framework for Personalized Financial Risk Profiling and Portfolio Allocation for the Sandwich Generation. Now, the motivation behind this work comes from a growing financial challenge which is being faced, especially by the sandwich generation. Now, this generation refers to the individuals who are simultaneously taking care of their aging parents and their dependent children, while at the same time they try to build their own financial future. Now, despite all of these responsibilities, currently there are no platforms in India that can combine real-time market intelligence along with financial risk profiling. So this is what motivated us to begin with this project. As I mentioned earlier, the sandwich generation is suffering through increasing financial pressure. According to recent surveys, nearly 60% of the Indian adults aged between 35 to 50 feel that they have insufficient savings, whereas more than half of them believe that they might even run out of money. Along with that, education costs are rising to approximately 8 to 10% per year, and for about healthcare expenses, it is increased up to 15% annually. And if we talk about traditional advisors, they are really expensive for the middle income household because they charge 1 to 2% of the assets under management annually. And it is difficult for people of the middle class background to provide that. Now, as for a problem statement, there were three gaps. The first gap is affordability. As I mentioned earlier, it is not possible for everyone to hire financial advisors for their needs. The second is your context gap. There are digital tools out there like SIV calculators and stock screeners, but they do not take the financial condition of a household into consideration. The third is your adaptation gaps. There are many recommendation systems out there, but they remain static despite of the market's behavior. Like there can be situations where there's a investor, but who's receiving the same recommendations even if the market is bullish or bearish. Now, for our objectives, we had four main objectives. The first goal was to identify the user's risk profile using personal household information. For this, we had used a random forest model. The second objective was to forecast the market behavior and classify the regimes as bullish, bearish, or neutral. The third objective was to combine these two using a fusion layer and to provide a portfolio allocation for our customers. As for the fourth and the last part was to display all of the work done through a dashboard using Streamlit. As for our proposed methodology, we have two intelligence systems running in parallel. So the first layer is processing the user data with the help of a random forest model and classifying the user's condition as an aggressive investor, a conservative, or a moderate. The second layer is your market data which is being processed using a LSTM model, and that is being used to predict the next day of the return of Nifty index. We have another additional layer as our momentum engine, which is calculating the momentum of each stock using a past 20-day cumulative return process. And all of these goes through the Fusion engine, which is being later on displayed on the dashboard using Streamlit. As for system architecture, we have 5 modules. The first is a user risk profile, which is a random forest with 200 trees and a maximum depth of 8. Using this, we were able to engineer 6 ratios. The second module was your LSTM, which is a 2-layer stacked LSTM model with a dropout of 20% neurons. The input shape for this model was a 30-day rolling window with 67 features obtained from our dataset. The third module is your stock momentum engine, which calculates the momentum of each stock using a 20-day cumulative return. And based on that, we display all the recommended stocks, whether the user is aggressive or conservative. The fourth module is your Fusion engine, which combines all these three and displays them onto the Streamlit dashboard. As for our experimental setup, for the user data, we got the data from Kaggle. It was named Indian Personal Finance. It had around 20,000 record information about the Indian household. From this, we were able to engineer 6 ratios and classify the data into 3 classes as mentioned earlier. For the market data, it was obtained using Yahoo Finance. At the moment, we have selected only 13 listed companies and we have excluded any type of international market as of now. We have also included Nifty 50 and Sensex indices as well. And these were the hyperparameters used. They were selected on the basis of trial and error experimentation. Well, as for our performance metrics, the random forest had achieved overall accuracy of 95%. The LSTM model had a validation score of 7.3 times 10 to the power of minus 5, which indicates that it had a strong predictive capability of analyzing the trend patterns. The ratios on the bottom right, which you can see, are the ratios which we had engineered. They were formulated with the help of weights so that we could add more importance to specific features. And if you can observe them clearly, our top 2 ratios, disposable and savings ratios, they together explain more than 60% of the random forest behavior, meaning that these two ratios alone can explain the decision-making capability of our model. Then we had compared our system with other studies found from the literature. The previous studies were either working on only risk profiling or market forecasting, but not on both. This is what makes our system unique from them because we are incorporating both of them. Along with that, we are only targeting Indian specific households at the moment. And this is a demo of what we had made, our prototype. As you can see, say the LST model is giving a predicted return of 0.008, and that is classifying the user as aggressive. Now, based on all these data, the momentum engine will calculate the top 5 scores. Say the user is aggressive, it will only recommend 5 scores, but if the user is conservative, it might only give 3 or not more than that. Based on the type of risk profile, we are providing specific number of stocks. Well, as for limitations, the current issues are that first of all, we are only focusing for the Indian market equity at the moment. We have excluded all international ETFs. The LSTM model is only predicting the next day return as of now, but we would like to, in the future, work transform that into multi-horizon aspect. Then third, our risk model is based off on a pseudo label. The reason behind it is because we had done rigorous searching for data sets, but we couldn't find any data set which was able to label users based on their financial condition. Fourth is a rule-based. The Fusion Engine layer is using a deterministic allocation rule system instead of a optimized um, formula. As our future work ahead, we would like to convert our pseudo labels into a certified validated labels by a financial planner. We can add macroeconomic labels like foreign investment flows or inflation to make the model's interpretability better. This then we can, as mentioned earlier, we can also use provide multi-horizon to the model so that it can predict much farther instead of just one day ahead. Third, we would also prefer extending our asset universe, including different ETFs and the markets which are available universally. As to conclude, WealthBridge is a hybrid platform which combines random forest and LST models to provide portfolio allocation and personalized risk profiling. The random forest was able to reach 95% accuracy on 4,000 held out in household profiles, whereas the LSTM was able to get a validation score of 7.3 times 10 to the power minus 5 in just 5 epochs. Well, I would like to express my sincere gratitude to the Department of Data Science and Engineering at Manipal Jaipur for their guidance. I also acknowledge the providers of the Indian Personal Finance Dataset and Yahoo Finance, which made this research possible. And finally, I thank the organizers of today's event for providing me the opportunity to present the work. Now, these are the references which I had used in my study. Thank you so much for giving me your attention. I would love to answer your questions.
Thank you for your presentation, sir. Do we have any questions? Since there are no questions, we will move forward with the session. So with this, we come to the end of the session. I sincerely thank our authors for their excellent presentations and contribution in this session, and all our participants for being part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support during this virtual conference. We'll be happy to have you again in the next version in 2027. All the uh, all the presenters will be getting their digital certificates within the all the presenters will be getting their digital certificates through email within 2 working days. The publication will be live within 7 to 8 months, so kindly cooperate with the team of TIBS 2026. I also thank the session chair, Dr. Deepika Virari, for chairing this session. I would like to present a token of appreciation to the chair on behalf of Team TIBS 2026 and Global Knowledge Research Foundation and partners. Thank you for joining us today, ma'am. Thank you, everyone. Just before we end the session, I request you all to kindly switch on the camera for a quick snapshot of the virtual conference. Can everyone please switch on the camera? All right. Thank you for joining today. You all may leave.